To talk about some of that technology, because we mentioned PEMF, RIFE, and everything, JG, can you go into how'd you come up with the combination of things that went into the biocharger? Because a lot of times when I see technology now, it is just let's try and throw, or even I'll talk about health in general, supplements. Let's try and throw in as many kind of cool, interesting ingredients into one pill, and then say it's a therapeutic kind of, answer to this. But you test it, and sometimes the synergy doesn't work. You can't just throw a bunch of ingredients in a pot and call it a Michelin star, meal and serve it to people. So how did you come up with the precise ones? And can you go into exactly what the different technologies are in BioCharger?
Surely. So as Jim mentioned earlier, there's the 4 different energy types. So we have that pulse magnetic fields. So magnetic fields work differently on a body than an electric field. So I guess I'll first start off with the electric field. So the electric field, you have this voltage, and how voltage or electric field impacts the cell is it affects the cell membrane itself. So the cell membrane acts like an insulator or dielectric, and it's actually a switch is what it is. So what happens in normal cellular function, you have these positive ion charges on the outside, you have these negative ion charges on the inside. It stresses the cell membrane, it creates a tiny hole which becomes an ion channel, and depending on how that ion channel, how big it opens and how quickly it opens and closes determines what type of protein is driven, what type of hormones are driven, or if it's just ATP function where you're moving sodium, potassium back and forth. But that electric field triggers that whole function. So until that ion channel opens up, nothing happens. So in healthy cellular function, that's what's happening. But unhealthy cellular functions, you begin to have these not enough charge to create that effect on the ion channels. So what the electric field is it stresses the cell membrane like an insulator or dielectric. So much like with an electricity and a capacitor, when you start applying voltage, higher and higher voltage to a capacitor, you begin to stress that insulation or dielectric that's within the capacitor until it finally short circuits or creates these little tiny pinholes. Well, same thing happens on a cellular level on the cell membrane. So as you apply high voltage to it, you begin to create these little tiny holes, which become ion channels that begin to create that healthy cellular function. So we're really not charging the cells up like a battery per se, but what we're doing is I look at it as it's like a battery charger that you don't have the switch turned on. So you have it all set up, it's ready to do its function of charging, but until you flip that switch on, nothing happens. And on a cellular level, the same thing happens. You have this electrical chemical reaction that's just sitting there ready to happen. And until that cell membrane opens up and gates, nothing is occurring. So that's that first effect. So with that voltage, we can begin to artificially open that cell membrane to begin gating it. Now, the magnetic field works completely different. So magnetic field isn't going to stress the cell membrane, but what the magnetic field does is it affects the charges. So you have, again, those ion charges on the outside of the cell membrane and the ion charges on the inside of the cell membrane. When you apply a magnetic field, much like when you go do an MRI, they expose you to this magnetic field and it aligns everything up. It aligns all those charged particles. So when that happens, then it helps to rearrange those ions that are on the outside and the inside to help naturally create that ion channels. So again, so they're working sort of the same, but differently. So the magnetic field helps to orientate the charges, or what we like to say is it helps to arrange everything outside and inside. And then the electric field is what gates it to allow it to move inside and outside. So we felt that those are 2 very important parts that are completely different that we saw in these different technologies that could be a benefit. So Lahosky in his original work had these high voltages, but we also have this frequency and harmonics. So frequencies and harmonics actually impact things differently. So again, back to that cell membrane with the electric field. So if we can gate and open and close it at a certain rate, how wide we open it, how long we open it will help drive specific ions depending on how we gate that. So as you begin to apply these variable frequencies and harmonics, you begin to affect the way in which the cell membrane is gating, which changes the different channels that are beginning to open up with it. But there's also another part of frequencies and harmonics that are more on that resonant effect. So when you think about it, everything vibrates. Light vibrates, atoms vibrate at the speed of light. As you slow it down, there's a molecular band spectra that's slightly lower to that. And then you have the the magnetic resonance. So everything in life is vibrating. Molecules are vibrating, the internal nucleus is vibrating, the cell membrane. So everything has its own unique vibrational characteristics. And you can transfer energy through those vibrations through sympathetic vibration, much like two tuning forks of the same pitch. If I strike one through sympathetic vibration, the other one will start to vibrate. But if I take two different ones, nothing will happen.